Techdaily.ai, your source for technical information. Welcome back to another deep dive. Today, we're jumping into something we hear about all the time now, migrating databases. Specifically, that big move, from Oracle over to PostgreSQL. It's complex, sometimes maybe a bit scary, but definitely trending. We've got a lot to unpack here, the reasons, the real benefits, the challenges, and crucially, how people are actually succeeding with this.
That's right. It's a major shift companies are looking at or are already deep into. And look, database migrations are never simple, right? But the arguments for open source like PostgreSQL are getting really, really strong.
Okay, so let's kick off right there. The why. What's
Yeah.
really pushing this? I mean, cost is the obvious one, always has been, but it feels like there's more going on now.
Absolutely. Cost is, well, it's often the starting point. You can't ignore it. Oracle's commercial licensing, it's expensive. You've got the yearly fees, sure, but then extra charges for things like partitioning, high availability features you might really need.
Right, things that maybe feel like they should be standard.
Exactly. And with PostgreSQL, it's open source, zero license fees. That's immediate financial relief, especially for big Oracle setups. It's a huge chunk of change. But like you said, it's definitely broader than just the money these days. Flexibility and freedom, that's a massive driver. Being locked into a single proprietary vendor like Oracle, well, it limits you.
Vendor lock-in. Yeah, we hear that phrase a lot.
And moving to open source PostgreSQL kind of breaks those chains. It opens up this whole ecosystem of features, extensions. It lets you tailor your database to what you actually need now and down the road without being tied to one company's decisions or pricing.
That flexibility piece sounds crucial for keeping up, for innovating. What about performance? Can PostgreSQL really go toe-to-toe with Oracle there?
Yeah, it absolutely can. PostgreSQL has a strong reputation for performance. It's particularly good, often noted for read-intensive applications. It handles high concurrency, lots of transactions really well. So many organizations moving aren't just looking to save cash, they're genuinely expecting performance boosts. And often, they get them. Better scalability too.
And the community aspect. That open source world must bring its own advantages.
Oh, invaluable. Seriously, the PostgreSQL community is incredibly active. You've got constant development, updates coming out regularly, excellent documentation, freely available, plus just a massive pool of expertise you can tap into online through forums, user groups, Slack channels, you name it.
So you're not just relying on buying support.
Exactly. You're part of this wider collaborative environment. It's a different feel.
Okay, so it sounds like all these things, the cost, the flexibility, performance, community, it's really about getting set up for the future, isn't it? Modernizing, being more agile.
Precisely. That's the bigger picture. For companies thinking strategically, this kind of migration fits right into modernizing their whole tech stack, paying down technical debt, and making sure they can actually adopt new tech, respond faster to changes, and, get a better long-term return on their whole data infrastructure.
Okay, let's talk about those returns, tangible stuff. Beyond just not writing those big license checks anymore, what are the actual, real-world wins companies are seeing? What's the ROI story?
Yeah, this is where it gets compelling, because it's not just about cutting costs, although that's nice. The migration itself, when done right, often boosts operational efficiency, developer productivity, that speeds up the ROI significantly. PostgreSQL's architecture, its features, how you can tune it, it often means you can handle workloads more efficiently. You see faster application response times, happier users.
And it probably makes it easier to adopt newer tech like cloud.
Definitely paves the way to better leverage cloud environments, containers, all that modern stuff.
We saw some specific examples, right? Some pretty impressive numbers.
Oh yeah, some great stories like the USDA Forest Service. They had this big Oracle geodatabase. Support was ending. They moved to PostgreSQL and saw performance improve by over 70%.
Wow.
And they did it for less than 30% of the original cost. Tasks that took hours, now done in like a quarter of the time. On smaller servers too. That's not just saving money, that's a huge capability jump.
A 70% gain is massive. What about the FBI example?
Right, the FBI. They needed to shift critical apps to AWS, needed better security there. But Oracle licensing in the cloud, very pricey. They used a specific PostgreSQL option that let them migrate cost-effectively with minimal disruption and, crucially, no data loss for these vital systems.
Makes sense for mission-critical stuff.
Then there's Ericsson, telecom giant, right? Re-architecting a massive content management system for huge volume, high performance. They switched to a specific PostgreSQL solution. Not only did they hit their scalability and cost goals, they actually doubled their content ingestion rate. Doubled it. from 5 titles a minute to 11.
Doubling throughput just by swapping the database. That's pretty incredible.
It really shows the potential. And Telegra in Germany, redesigning their IT for more agility. They moved from commercial databases to a specific PostgreSQL setup. They got better reliability, cut costs way down, simplified how they manage things, and they specifically mentioned getting better security and flexibility than their old closed-source system.
Interesting. And Metasphere.
Metasphere, yeah, the telemetry company.
Mhm.
Oracle's pricing, especially its on-prem focus, was actually holding back their international growth plans. Too expensive. Moving to PostgreSQL slashed their licensing costs, not just for them, but for their clients too. That let them offer better pricing, expand into new markets with both cloud and on-prem options.
These examples really drive it home. The benefits are way beyond just the license fee. It's about enabling new things, new efficiencies.
Totally. That open source flexibility lets you redirect resources. Instead of pouring money into licenses, you can invest in using your data better AI, analytics, handling bigger transaction volumes, strategic growth stuff.
Okay, the why is clear, the benefits are compelling. Let's get practical now. The technical side. What are the real differences? What compatibility issues, what headaches do you actually run into moving from Oracle to Postgres?
Right, this is where the planning really needs to be thorough. Because while they're both solid relational databases, both ACD compliant, which is good, your transactions are safe, they're different beasts under the
Like
hood.
how you actually talk to them, the SQL itself.
Exactly. They use different SQL dialects. PostgreSQL is generally closer to standard SQL, with its own extensions PLPG SQL for procedures. Oracle has its own long-established variant and uses PL SQL, a key structural difference too. Oracle groups related procedures and functions into packages. Standard Postgres doesn't have packages. It uses schemas to organize things similarly.
Okay, different dialects, different structure. What about data types? Can you just map them one-to-one?
Rarely that simple, unfortunately. This is a really common tripwire. Not every Oracle type has a direct, perfect match in Postgres. For instance, Oracle's BFile EAL type points to external binary files. Postgres doesn't really have a native equivalent. Oracle handles numbers differently too. Its float is fixed precision. Postgres uses true floating point, the common Oracle number type. Usually maps to numeric or decimal in Postgres, but you have to watch the scale and precision carefully.
Dates and times, too.
Yeah, they differ. Oracle's date type holds both date and time. Postgres separates date and time or uses timestamp. And Oracle's timestamp with local time zone needs very careful handling during migration because of how it deals with time zones.
So you definitely can't just take an Oracle create table script and run it on Postgres.
Nope. Not without transformation. Now, the good news is applications can connect to both using standard methods, ORM frameworks, drivers like JDBC, ODBC.NET. That helps with the connection part. But it doesn't fix those underlying schema and code differences. Interestingly, Postgres also tends to play well in environments that also have SQL Server, which gives you some flexibility in mixed shops. And they both share core concepts, right? Views, keys, triggers, stored procedures, but the syntax, the implementation details can definitely vary.
Got it. So differences are clear. How do people actually do the migration then? What tools, what strategies help bridge these gaps?
Well, a full migration isn't just one step. You've got to convert the schema, rewrite application logic queries, store procedures, then migrate the data itself, and update how the apps connect. Trying to do all that manually, forget it unless it's a tiny database. It's just too complex, too error-prone.
So automation is pretty much essential.
Absolutely essential. There are basically two main automated routes people take. First is the translation approach. Use tools that analyze your Oracle stuff, schemas, queries, procedures, and try to automatically generate the equivalent code for standard PostgreSQL. Think AWS Schema Conversion Tool, SCT, Oracle's own SQL Developer Migration Wizard, or open source tools like Ora2PG.
Okay, what's the good and bad with that?
The big advantage is you're aiming directly for community open source Postgres. The downside, these tools often struggle with the really complex proprietary Oracle features. You'll almost always need significant manual cleanup and rewriting afterwards, and maybe application changes too. Best fit for simpler databases using mostly standard SQL.
Makes sense. And the second approach?
That's called the native compatibility approach. This is different. Instead of just translating, it uses a specific version of PostgreSQL that's been extended to natively understand and run many Oracle-specific things.
Ah, so it understands Oracle's language better.
Kind of, yeah. It means it can migrate a very high percentage, like over 90% sometimes, of your proprietary Oracle logic with minimal changes needed in your application code. That can save a ton of rewriting effort.
What's the catch?
The trade-off is You're migrating to a specific proprietary distribution of PostgreSQL, not the pure community version. So it's often the choice for those really complex databases that rely heavily on things like stored procedures, packages, or specific Oracle features like DB Link.
Okay, translation for simpler stuff, targeting open source, native compatibility for complex logic if you're okay with a specific Postgres variant. What about just moving the terabytes of data?
Yeah, for the actual data movement,
Hmm.
tools like AWS Database Migration Service or DMS are popular. They handle the big initial copy and, really importantly for live systems, the ongoing replication of changes that's change data capture, or CDC, keeping things synced until you're ready to flip the switch.
And project management strategies,
Mhm.
especially for huge systems.
Yeah, definitely. Incremental migration is common, breaking the whole thing into smaller, manageable phases. Less risk, less downtime, more chances to test along the way. Or a phased migration approach, start with maybe less critical apps first. You learn the process, build confidence, iron out kinks before you tackle the really big, scary, business-critical ones.
Okay, plan well, choose the right approach and tools for the job, break it down, seems logical. But even with the best plans, where do things typically go wrong? What are the common hurdles, the pain points?
Yeah, even with good planning, you'll likely hit bumps. Those data type conversions we talked about. Super common source of issues, like how Oracle treats empty strings as NUL, but Postgres sees them as actual empty strings. Seems small, but it can break application logic or even mess up performance if indexes don't work as expected. You really have to analyze and adjust types during schema conversion.
And the application itself, making sure it still works.
That's the other big one, application compatibility. All those differences in stored procedures, triggers, how NLLs are handled, they often surface as bugs in your application code after migration. So you've got to comb through the code, make changes, and then test, test, test. Every function inserting data, retrieving it, complex processes needs thorough validation.
And performance tuning, getting it to run fast in the new environment.
Definitely a post-migration challenge. A query that flew on Oracle might crawl on Postgres, or maybe the other way around. Their optimizers just work differently. So you need comprehensive performance testing after the move. Then you start leveraging Postgres-specific tuning techniques, tweaking configurations like memory allocation, shared buffers, workmem, connection settings, indexing strategies. Getting it to Oracle-level performance or better is definitely possible, but it takes dedicated tuning effort on the Postgres side.
Are there specific Oracle features that are just notoriously difficult to replicate in Postgres?
Oh yeah, things like Oracle's virtual columns, or its synonyms, often require workarounds using views or triggers in standard Postgres. But interestingly, surveys suggest the absolute hardest parts aren't always the obvious schema differences.
Oh, what tops the difficulty list then?
Well, migrating the actual data for very large databases, handling that initial load and the ongoing change data capture efficiently, that often comes out as the most difficult part. But right behind it, moving the application away from Oracle's proprietary drivers and interfaces.
Wait, the drivers, why are they so hard? Aren't they just connectors?
You'd think. But Oracle's standard drivers, JDBC, ODBC, .NET, often have specific extensions built in that applications rely on, maybe for calling procedures or handling data types in a certain way.
Right.
And worse, if your application uses really low-level Oracle interfaces like OCI, Oracle Call Interface, or ProC, embedded SQL and C code, that logic is deeply tied to the Oracle's internals. There just aren't direct open-source equivalents for those.
Ah, so replacing those isn't just changing a connection string, it's deep application surgery.
Exactly. You often have to significantly rewrite how the application talks to the database at a fundamental level. That's a huge effort.
So it sounds like a lot of the hidden difficulty is tied up in that business logic, whether it's in stored procedures or embedded in the application's connection code.
That's a major part of it, yes. Especially complex stored procedures. If you're relying purely on translation tools, they often choke on tricky Oracle constructs. Things like pragma autonomous transaction, letting a sub-procedure commit independently, or Oracle hints that force the query optimizer. Those are super hard, sometimes impossible, to replicate directly in Postgres. They usually force significant logic rewrites.
So it's really not just the database swap, it's often application refactoring too.
Very often, yes.
Okay, let's zoom out a bit. Just comparing Oracle and PostgreSQL more generally, functionality, ease of use, day-to-day, how do they stack up?
Well, we keep coming back to cost because it's such a stark difference, right? Postgres Community Edition, zero license cost. Oracle Enterprise, potentially tens or hundreds of thousands per core, plus extra for key features.
Yeah, the sticker shock is real.
Even with discounts, Oracle scales expensively. Functionally, though, Postgres has really matured. For core database features, it's often considered on par with Oracle now. Both scale, but Postgres gives you massive scalability potential for free, whereas Oracle's top-end scaling is locked behind its priciest additions.
Updates and security.
Postgres has a very predictable, transparent release cycle, annual major releases, quarterly minor ones. Oracle's is less frequent, maybe every 2–4 years. Security-wise, Postgres has strong built-in options and free encryption plugins. Oracle's advanced security is a costly add-on. Same for replication. Postgres has native streaming and logical replication. Oracle relies on the separately licensed Golden Gate for modern replication.
How about just using them day to day, which is easier?
This is where that open source community and ecosystem really benefits Postgres. You have this huge range of free tools and extensions for everything from spatial data, PostGIS, to scaling, SysDB, to performance tuning. Support is everywhere, free, through the community. Oracle has enterprise tools, sure, but often they cost extra. Finding expert help. Available for both, but Postgres experts might be more reasonably priced.
And compatibility.
Postgres's procedural language, PGSQL, is generally seen as more compatible with other databases, which can simplify things. Oracle's ecosystem can feel a bit more walled off. Tuning-wise, Postgres is often considered a bit more straightforward, focusing on the query optimizer, explain plans. Oracle can involve more complex tuning parameters and often relies on license packs like AWR for deep dives.
So functionally strong, way cheaper, maybe easier to work with thanks to the community. It really paints a clear picture of why this shift is happening. Do companies usually just flip a switch and move everything?
Oh, rarely.
Yeah.
Especially big companies.
Right.
What you usually see is a transition period. They run both. New projects, maybe they start on PostgreSQL by default, then they gradually migrate existing Oracle apps over time. It becomes a hybrid environment for a while.
Right. You outlined the big steps earlier. Can we walk through that 9-step migration journey in a bit more detail? What does that actually look like?
Sure. Think of it as stages. 1. Decide. That's a business case, setting priorities, getting everyone on board. 2. Analyze. Feasibility. Look at your apps, figure out cloud versus on-prem, open source strategy. 3. Plan. This is key. Prioritize apps. Pick your migration approach, translation, or native compatibility. Design the target setup. Estimate the work. 4. Core migration. The technical heavy lifting. Convert schemas, rewrite database code, get that initial data snapshot moved, set up CDC. Outcome, a basic working Postgres DD. 5. Application integration. Update the apps, change APIs, convert embedded SQL, get the applications talking to the new database correctly. 6. Tool migration. Move your reports, DBA scripts, management utilities over. 7. Test. Hugely important. Validate the data, test all application functions, check performance against requirements. This is iterative. 8. Optimize and configure. Post-migration tuning. Optimize queries, tweak database settings, set up high availability, disaster recovery, security properly in Postgres. 9. Cutover. The final leap. Finish the data sync via CDC, have rollback plans ready, make the go-no-go call, switch production over. Done.
That's a very clear roadmap. And you mentioned prioritizing applications, finding the easier ones to start with. How do you figure that out? What makes an application an easy win?
Good question. Experience shows there are definitely characteristics to look for. You want apps with less complex Oracle-specific code.
Like what specifically?
Well, apps using an ORM tool like Hibernate or Spring tend to be easier. The ORM handles a lot of the database interaction, hiding some specifics. Also, if the database logic, the procedures and functions are all written in PL/SQL, that's generally easier than if they used Java store procedures inside Oracle.
Access to the source code helps too, I bet.
Massively. If you can actually get in and modify the application code, that's a huge plus. And apps that don't rely on Oracle's really high-end stuff like RAC for scaling or Flashback for point-in-time recovery, those are simpler targets. Oh, and having a good set of automated tests already. Gold dust makes validation way easier. Maybe half of databases fall into this easier category, potentially migrating in, say, 10–20 person days.
Okay, so ORM is pure PL/SQL, source code access, no fancy features, good tests. What about the next tier, the slightly harder ones?
Yeah, the second group, needing more work. That includes apps using Oracle's low-level OCI interface, or ones heavily using Oracle Spatial or Oracle XML features. Also, apps relying on those Oracle-specific extensions to standard .NET or ODBC drivers. Those often need more specialized tools or maybe expert help. This might be another, say, 25–30% of databases.
And the real tough nuts, the ones you tackle last.
The most difficult. Often apps using the old Pro-C interface embedding SQL and C code. Very legacy, very tricky. Apps with really complex transaction logic inside PL/SQL explicit commits, rollbacks, save points, complex exception handling, those Java stored procedures we mentioned, and anything that absolutely must have RAC-level scalability or flashback capabilities. Those require fundamentally different approaches in Postgres, possibly significant re-architecture.
Those guidelines seem super useful for planning. Start with the easier ones, build momentum.
Exactly. Use that as a filter during planning. Identify the low-hanging fruit, get some wins, learn the process, then tackle the bigger challenges.
This has been incredibly insightful, really breaking down this whole Oracle to PostgreSQL shift. We've hit the strong business drivers cost, yes, but also that strategic push for flexibility, open source innovation, performance potential. And we've also got a much clearer view of the technical hurdles. It's not trivial, right? Dealing with data types, SQL differences, complex procedures, those tricky proprietary interfaces.
Absolutely. It's a significant undertaking, especially with large, heavily customized Oracle estates. There are definitely technical challenges. But as we saw with those examples, success is very achievable. It comes down to meticulous planning, choosing the right migration path and tools for your specific situation, and being ready to put in the work on transformation and tuning.
And the long-term benefits in cost savings and just sheer agility seem like they can be pretty substantial.
Yeah, it can really reshape how an organization manages its data and innovates moving forward. It's often a strategic investment, not just a tech project.
Well, thanks for walking us through all the layers of this. It really underscores that blend of, high-level strategy and deep technical execution needed. Definitely gives you a lot to think about regarding your own data setup, doesn't it? This podcast is sponsored by Stonefly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.